In the previous section, we talked about what happened to the mean or the expected value, the standard deviation, and the variance of a random variable if we added a constant or multiplied by a constant. Now we're going to find out what happens if we add together or subtract two different random variables. So let's go back to the dice game. In the original dice game, here was the point values that we got and their probabilities based on what numbers you rolled. So if you rolled a 1, 2, or 3, a 4, or 5, or a 6. Here is the mean, standard deviation, and variance for that game. Then in the third game, the second variation of the game, we subtracted 5 from all of the original points. So notice the spread is the same, so the mean changed, and that should say 5 and not 15. The mean changed, but the standard deviation and the variance stayed the same. Now what I want to think about is, let's say we rolled 2 dice. And let's say when we rolled the red dice, we used this point distribution, and we rolled the green dice, we used this point distribution. And we're going to add together the points that we got based on the red roll and the green roll, and that would be our points total. So I want to find out the probability distribution of x plus z, where x is the point scored when we rolled the red die, and z is the point scored when we rolled the green die. So let's think, the first thing we have to do is think about what are all the possible values of x plus z and their probabilities. So for example, so here's x plus z and probability. So one thing I could do is I could roll, for example, I could roll a 1 on the first die, and I could roll maybe a 3 on the second die, and I would get a 0 points here and -5 points here, and I add them together, I would get -5. So one possibility would be rolling a 0 on one, getting 0 points with one die and -5 with the other, which would be a total of -5. And I have the probability of both of those things happening, this thing and this thing, since they're independent events, I would just multiply their probabilities. So that's 1/2 times 1/2, or 1/4. A second thing that could happen would be that I would roll a 1, 2, or 3 on this die and get a 0 points, but I'd roll a 4 or 5 on this and get 0 points. So I could also get 0 plus 0, which is 0. There'd be a 1/2 times a 1/3 chance, or a 1/6 chance of that happening. And then I could roll a 0, a number that would give me 0 over here and 45 over here. So I could do 0 plus 45 equals 45, and I'd have a 1/2 times a 1/6 chance of that, or a 1/12. Okay, then I could do, for example, 5 here and a -5 here. So 5 plus -5 is equal to 0. There'd be a 1/3 times a 1/2, or a 1/6 chance of that. So notice this outcome is the same as this outcome. There's 2 different ways to get it. So we can continue on. There'd be 9 different outcomes altogether. Now here I've listed all the 9 outcomes and all their probabilities, and then I wanted to condense them a bit. So there's one way to get a -5, which is right here. I've got this one. There are 2 ways to get a 0. There's this way, which has a 1/6 probability, and this way, which also has a 1/6 probability. So if I add together 1/6 plus 1/6, I get a 2/6 or a 1/3 probability. Then there are 2 ways to get a 5. No, there's only one way to get a 5 right there. 45, there are 2 different ways to get a 45, 1/12 and 1/12. So 45, 1/12, 45, 1/12. So this one is right here, 1/12 plus 1/12, which gives me 2/12 or 1/6. There are 2 ways to get 50. Those add up to a 1/9. 1/18 plus 1/18 gives me 1/9. And then there's one way to get 95. So this is my complete probability distribution now. Now what I want to find out is the expected value, the variance, and the standard deviation. Now we can get that using the formulas, but I'm not going to do the formulas. I'm going to do it on my calculator. So let's go to the calculator. So I've created a frequency distribution here, or the probability distribution on my calculator. So here's the x plus z. Unfortunately, you cannot use the plus sign in a title here, so I just wrote out x plus z. So here are all the different values that x can be. And then this was supposed to be the probability of x plus z, but I wrote xmz. It should be pz, x plus z. So when I do this on my calculator, then I'm going to go to a calculator page. And then I'm going to do menu 611, which is one variable stats. This is one list of data. My x list is x plus z. My probability was the probability of xmz. I wrote the wrong thing there. And so here we have my values here. So the ones I'm looking at is x bar. That's the expected value or the mean. The sigma, 25.495. And then the standard, and then the variance, which is 650. So I'm going to go fill in those. So from the calculator, we get these values. This is 15, this is 650, and this is 25.495. Now, if you look up at our values up here, 15 makes perfect sense because remember we changed this number to a 5 here. This is not a 15, it's a 5. E to the x plus e to the x, expected value of x plus expected value of z would be 10 plus 5. So that makes perfect sense that that's 15. Okay, that is very understandable. Similarly, when we look at the variance of x is 325, and the variance of z is also 325. So this is just 325 plus 325, which is 650. So that makes perfect sense too. Now standard deviation, however, is a little different. Our two standard deviations here are 18.03 because these have exactly the same range, so their spreads are not any different. But adding 18.03 and 18.03 is 36.06. This is not 36.06. So what happened with the standard deviation? So we know one thing, and this is important to know. The standard deviation of two random variables added together is not the sum of their standard deviations. So this is not equal to standard deviation of x plus standard deviation of z. You cannot add standard deviations. So what exactly did we do? Well, let's start with what we know. We know that the variance of x plus z is equal to the variance of x plus the variance of z. We also know that the standard deviation is the square root of the variance. So the standard deviation of x plus z would have to be the square root of the variance of x plus the variance of z. So the standard deviation of x plus z, well, since the standard deviation is the square root of the variance, we also know that the variance is standard deviation squared. So we can rewrite this as the standard deviation of x squared plus the standard deviation of y squared. This is known as, kind of informally, as the Pythagorean theorem of statistics. Remember Pythagorean theorem, a squared or c squared equals a squared plus b squared. So to find c, we would take the square root of a squared plus b squared. So we kind of call this the Pythagorean theorem of statistics. Okay, so in other words, c squared equals a squared plus b squared, so c is the square root of a squared plus b squared. So that's basically what we're doing with standard deviation. So testing it out with the specific numbers, we know up here that the standard deviation for each individual random variable is 18.03. So let's check this out. So the standard deviation of x plus z is equal to the square root of 18.03 squared plus 18.03 squared. We do this on the calculator. So get it all set up for you. Push enter. There we go. 25.4. Oh, I had a point. Put a 2 in there. Didn't mean to do that. But anyway, 25.495. And let me just enter, and let's just take that 2 out, and we get a much closer value. Okay, 25.498. Now, realize this is a rounded number, so it's not exactly what we have there, but if we had not rounded that number, we would have gotten exactly the 0.495. So this is the 25.495. 0.49. Okay. All right. So this gives us, this is how we find the standard deviation when we add together two random variables. Now let's examine another alternative to adding two random variables. Now let's subtract them. What happens if we subtract the two random variables? What happens to the expected value, the variance, and the standard deviation? So I've created a probability distribution for the difference of two random variables. So set up the same 9 different possibilities and their probabilities. Now notice the probabilities for the differences is the same as the probabilities for the sum, because we're still saying 0 and -5, and then we're just subtracting them instead of adding them. The combinations of numbers are different. Everything only has one possibility except the 5s. There's 3 different ways to get a 5. And so if we add up 1/4 plus 1/9 plus 1/36, that ends up being 14/36 or 7/18. So that's the only kind of odd one. And here are the other possibilities. So we're going to do the same thing on the calculator, is set up all of these values and their probabilities and find the expected value, the standard deviation, and the variance. And I think I'm going to put this in the other order since I wanted to do standard deviation last. So variance of x minus z, and then standard deviation of x minus z. So let's see what happens. Okay, so I've set up x minus z and the probability of x minus z just using an underscore here. So let's do add a calculator page, do menu 611, one list, x list is x minus z, probability of x minus z. Okay, so what do we get? Interesting. X bar, or the mean, is 5, but the standard deviation and the variance are exactly the same. So why is that? Interesting. So we see this is the same as e to the x minus, or sorry, expected value of x minus expected value of z, which is 10 minus 5, which is 5. So this is 5. The variance is 650, which is the variance of x plus the variance of z. Interesting. Not minus. So we subtracted the expected values, but we did not subtract the variances. We still added them. So this is still 325 plus 325. And this is still 25.495, which would be the standard deviation squared of x plus the standard deviation squared of y, sorry, z, not y, taking the square root of that. Okay, so that was what we did before, the square root of 18.03 squared plus 18.03 squared, which gave us the 25.495. So why is it that the expected value did what we expected, but the variance and the standard deviation did not? So let's go to the next page and kind of summarize